Welcome back, Algebra 2 students. We're in lesson 69. We're going to talk a little bit about those gas law problems that we did once upon a time. And if you don't remember the formula, for those of you who are new, this is the formula for gas laws. It is pressure, the original pressure times the original volume divided by the original temperature is equal to the final pressure times the final volume divided by the final temperature. Now, whenever any one of these components is held constant, we can drop that from the equation. So, if volume doesn't change, if the original volume is held constant and it's the same in the beginning as it is in the end, then our problem looks like this. P1 over T1 equals P2 over T2. That's when volume is constant, okay? When temperature is constant, then we drop temperature from the equation. So it becomes the original pressure times the original volume is equal to the final pressure times the final volume. And when pressure is held constant, then it looks like the original volume divided by, I don't know why I made that an I, losing my mind. The original volume divided by the original temperature is equal to the final volume divided by the final temperature. So those are the gas law formulas that we use when reading a word problem. So let's talk about what we're going to do differently. What we're going to do differently is we are going to solve these gas law problems in terms of one of the variables. And then we're going to do the answer, or we're going to use for the values in the problem, we're going to use scientific notation. So kind of a two-step problem. So let's jump into 69.1. If you haven't written this down in the back of your notebook, you really should, because we're going to use this more than once. These are good formulas to remember. So pause the video, write this down in your notes or on the back cover. This one should go on the back cover. Okay? This should go in your notes. This is to remind you how to change this, okay? But this is the original formula. Put this on the back cover, put this in your notes to remind you how to alter the formula when you need to, when one of these is held constant. All right, so pause the video, write that down, then press play. I'm about to clear the page. All right, let me type in our first problem and then we'll jump into it. All right, here's our first problem. This is 69.1. All right. A quantity of an ideal gas had an initial pressure, volume, and temperature of the values given. And we have to find the final temperature if the final pressure was this and the final volume was this. So we're going to begin by solving for T2. So what this means don't worry about this yet. This means let's figure out the format of the problem and where to drop our variables into before we have to deal with these complicated numbers. So let's start with the original formula. P1 V1 over T1 equals P2 V2 over T2. We want to solve for T2. That means we need to get to the point where we say T2 equals this. All right? So when we have fractions and we have an equation, we know we can get rid of the denominator by multiplying by the common denominator, the whole thing, right? So what that means is we can take T1 times T2 and multiply it times this side, and T1 times T2 and multiply it times this side. So what happens is T1 cancels, and because this is a whole number, it's over 1, this is going to be times this. So we end up with T2 times P1 times V1 equals, this cancels over here, and because this is a whole number, it's over 1. So this is P2 times V2 times T1. Now, we have everything multiplied. We have 3 factors on this side and 3 factors on this side. So all we have to do to get rid of these factors is do the inverse operation, and we know that's division. So we're going to divide on both sides by P1 and V1. Because this divided by this and multiplying cancels each other out. Multiplication and division by the same number cancels it out. We factor it out of our denominator, right, and our numerator. So now this is equal to T2 is the same as P2 times final pressure times final volume times the original temperature divided by the original pressure times the original volume. That is our final formula. That's what we need to look for. All right, so write all of this down in your notebook. Pause to do so. I'm going to put this over here to the side because we need to refer to that. Okay? But this is what you should be writing down as we do these problems. If you need more time, pause the video and take your notes. I'm going to clear this out so we have more room to solve the problem. All right. Now that we know what the format is, we can just start dropping these values in here. I'm going to move this over here to the middle so you can see it a little bit better. Okay, here's our format. All right, so now we're going to drop these values in. We don't know what T2 is. That's what we're trying to find out. I'm going to go ahead and draw a big long line because these are big long numbers. And now I'm going to start dropping the information in. All right, we have P2, V2, and T1. And then on the bottom we have P1 and V1, right? Okay. Maybe I might need more room. Just a little bit. All right, so final pressure, that's what goes right here. Final pressure was this, okay? So let's put the final pressure in for P2, 0.0004 times 10 to the 15. All right, now we need to do final volume. Final volume was this, 0.015, make that clear, that's the decimal, times 10 to the negative 14. Okay, and now original temperature is right here, original temperature. So the original temperature was this. All right, pressure, volume, temperature, pressure, volume, temperature. So we put the original temperature, 700 times 10 to the 4, right here. All right, now we've got the top part done. Now to the bottom part, we need the original pressure. Okay, that's that first number that was given to us, initial pressure. All right, so 40 times 10 to the 4. Okay, that's that number. And we only have one number left, and it's this one. So it goes right here, 0.0003 times 10 to the negative 6. All right, so now we have all our numbers in. So the first thing we need to do is we need to put them in standard scientific notation. They are not there right now. Right now, they are kind of in all over the place scientific notation. Let me zoom in a little bit. Okay. That's a little bit better. So now we can kind of see more up close. So what we need to do, let's rewrite this. T2 is equal to, and I'm just going to redo it. And I'm going to put the first one in. But first I'm going to adjust this so that it's in a simpler scientific notation, and I'm going to just have a single digit here. So if we move to the right, we are we subtracting? Yes, we're subtracting. We move to the right because it's the opposite of the number line. So if we move to the right, it's negative. So 1, 2, 3, 4. That's a negative 4. So 4 times 10, 15 minus 4 is 11. That's a much easier number to work with. Okay, now to the second one. We're going to move it 1, 2 places, okay, because we moved it to the right. It's subtraction. So that's going to be 1.5 times 10 to the negative 16. Okay. Last one, we're moving to the left this time, so we're going to add 1, 2, so that's plus 2. So 7 times 10 to the 6. All right, those are all of our top numbers simplified to the ones place, which is what scientific notation should be about. This looks a little wonky. This should be an exponent. Miss Tracy's handwriting is sus. All right, here we go. This one is going to the right, so it's going to add 1. So 4 times 10 to the 5. And now we're going to do this one. We're moving to the right, so we're going to subtract 1, 2, 3, 4 minus 4. So it's going to be 3 times 10 to the negative 10. Awesome. Let's scroll up a little bit. Now we're going to solve this. T2 is equal, and I'm going to go ahead and put my line here. Okay, now let me pull up my calculator. So the first thing I'm going to do is I'm going to say, I'm going to multiply my whole numbers, right? 4 times 1.5 times 7 equals 42. All right, 42 times 10. Excuse me, supper's coming back. Now we know we just add our exponents together whenever we multiply. So 11 minus 16 is going to be negative 5. Negative 5 plus 1, or plus 6, is going to be a positive 1. So times 10 to the 1. You don't have to write the 1, but there it is. Okay. Now, the only thing that I would do differently here is I would take this decimal point and I would move it over to here. So that's going to be a positive 1. So this is going to end up being, let me erase this, that equals 4.2 times 10 to the 2. Okay. Now let's do the bottom. 4 times 3, that's 12, times 5 minus 10 is 10 to the negative 5. Only same thing. We're going to move this over. So that's 1.2, and then we're going to add 1. Right? So 1.2 times 10 to the negative 4. Okay. Now all we have to do is divide. And we divide our whole numbers. We always do the whole numbers first. So 4.2 divided by 1.2 equals 3.5. So equals 3.5 times 10. And we know when we move this up to the top, that becomes plus 4. It was minus 4 down here. So to get rid of this, we bring it to the top because we treat this like a variable with an exponent. That's all this is. This is a variable with an exponent, so we're going to bring the variable with the exponent up to the top. So that means our exponent changes from a negative to a positive, so we add these together. So that's going to be 10 to the 6. All right, let's see if the book agrees with me. And it does. And because this is temperature, our temperature is given to us in Kelvin, which is a capital K, this would be the correct answer. Okay, so yeah, it's a few steps. It's a few steps. First, we had to figure out what this was going to be, right? We had to solve in terms of whatever it told us to solve in terms of. Okay, let me bring this back down so we can see the whole thing. So when it says find the final temperature, we know the final temperature is T2. So that's why it told us to begin solving for T2, because that is the final temperature, and that's what we were supposed to find. Okay, find this, and that equals T2. So we take our original formula, we solve for T2, Then we turn around, we drop these in just like substitution values into an equation. We simplified it into a better form of scientific notation. And then we just did the math. We multiply the whole numbers first, then we add the exponents on the 10. We just treat this times 10 with an exponent just like a variable. We just treat it like a variable. So we just add the exponents together. It's times 10 is the base variable, and the exponents get combined. And then that is how we solve it. Then we get our number down here. We divide the whole numbers, and then again, we treat this like a variable, bring it up to the top and change the sign, and then we have our answer. All right. It's a little bit convoluted and time-consuming, but that's probably why they only give us one more problem. So let's do it, and we'll be done with this lesson. So I'm going to clear the page. And I'm going to type the next one because, again, my handwriting stinks. I'm going to pause it for you. All right, here we go. This is 69.2. Okay, I'm going to first read it through. A quantity of ideal gas had initial values of this, this, this. Find P what? P2. All right, find the final pressure if the final volume was this and the final temperature was this. Okay, so we got to find P2. We got to find the final pressure. So let's put in our original formula. P1 V1 over T1 equals P2 V2 over T2. Okay, so now we're going to solve for P2. So again, we do the same thing we did before. We're going to multiply to get rid of the denominator. So T1 T2 times both sides. T1 T2. This cancels this. This cancels this. So T2 times P1 V1 equals P2 times V2 T1. So we're solving for P2. So we're going to divide both sides by V2 T1, V2 T1. So our final is going to look like this. P2 is equal to, and you can flip it, it's the law of equality, T2 times P1 times V1 over V2 times T1. Okay, so you see we just solved it in terms of what we had to find, which was P2. So now we know that P2 is equal to this. All right, pause if you need to. I'm fixing to erase. All right, and I'm going to move this to, oh, wrong one. I'm going to use this. I'm going to move this over here. Oh, let me see if I can just grab this. Nope, it's not going to let me. All right, well, I'm just going to rewrite it then. P2 is equal to T2, P1, V1 over V2, T1. All right, and then I can erase this out of the way. All right, that's fine. That works. All righty, so now we can drop in our values. So P2 is equal to T2. All right, final temperature. Final temperature was this, okay? So final temperature times original pressure times original volume, all over final volume times original temperature. So final temperature was 0.003 times, you know what, I'm going to skip a step here. And I'm going to go ahead and reduce this or solve this out. So 1, 2, 3. Oh, come on. 1, 2, 3. So that is going to be subtracting, so minus 3. So that's going to be 3 times 10 to the 4. All right. So let's do the original pressure. All right. Pounds per square inch, or pounds per inch, that is pressure. So this is the original pressure. So again, 1, 2, this one's 3. So it's going to be minus 3, right? So 3 times 10 to the 11. All right, and then our original volume. Our original volume was this, because centimeters cubed, that cube is a volume. So I'm going to put this in scientific notation. So 1, 2, 3, that is going to be 7 times 10 to the negative 3. So 7 times 10 to the negative 3. All right, now I need the final volume, which was this, and it's already fine, so I can just write it exactly the way it is. And then the original temperature, which is 7,000 K, which is not in scientific notation at all. So 1, 2, 3 here, it's going to be 7 times 10 to the positive 3. So 7 times 10 to the positive 3. All right, now I can just multiply the whole numbers, right? So I'm going to pull out my calculator because I can. Ha ha ha. All right, 3 times 7. 63. So P2 equals 63 times 10. 4 plus 11 is 15. 15 minus 3 is 12. Okay. 3 times 7 is 21 times 10 to the 5th. All right. Now, I could go ahead and move the decimal and change this, but looking at these two numbers, I can see that 3 times 21 is 63. So I'm not going to do that step at all, because I know that my answer is going to be a whole number. So I won't that's like a wasted point. So 63 divided by 21 goes 3 times. All right, and when I bring this up to the top, that becomes a negative 5. So times 10 to the 7. And because this is pressure, we write it with the same pressure, and that becomes pounds per inch. And that is the answer. Ta-da. It's not super hard once you figure out the steps. And the steps are to solve for what you're looking for just using the formula variables, then sub in the actual values and go ahead and simplify the scientific notation in the process. And that's going to make it easier to do the calculations. Okay, and then just multiply the whole numbers, add the exponents, multiply the whole numbers, add the exponents. Okay, once you get that done, then you divide these numbers and then you combine the exponents. You flip the sign, when you bring it up, and you combine them. And then that's your answer. All right, and that's all we have for lesson 69. I'll see you guys in lesson 70.